This is a video to help you finish up the investigation for rotations. Just going to go real quick through these, and sometimes I'll just fast forward. This is a clock layered on top of a circle of radius length 1, right? You see how the radius for each direction is 1, so 1. It is called a unit circle for that reason, because it is 1 unit in radius. Use the grid to estimate the x and y coordinates of each hour marker to 2 decimal places and write your estimate on the diagram. The hour markers are evenly spaced. What is the exact angle between each hour marker? 30 degrees, right? Because 360 degrees divided by 12 hours, 30 degrees, okay? You could also take 90 degrees and divide it by 3, you also get 30 degrees. Okay. So let's look at each one of these and see exactly what the coordinates are. So for this one here, it looks like the x-coordinate is exactly 0.5. The y-coordinate looks like it's between 0.8 and 0.9. I would say it's closer to 0.9 than 0.8, so maybe I would say 0.87. Okay. And you could say the same for all the ones that are, look at that, that's like a reflection, right? We learned about reflections. Reflections are symmetrical about the y-axis in this case. So I'm going to put here, instead of 0.5, 0.87, I'm going to put negative 0.5, 0.87, because the x-coordinate is negative, right? And I can do the same thing for these ones on the bottom. I could say that this one here is negative 0.5 and negative 0.87. And then this one here would be positive 0.5 in the x direction and negative 0.87 in the y direction. Okay. How about this one here? This one looks like the x-coordinate would be maybe 0.87, and the y-coordinate would be 0.5. Then we're going to reflect this about the x-axis, and we're going to get 0.87, negative 0.5. And then we're going to reflect it about the y-axis, and we're going to get negative 0.87, negative 0.5. And then we're going to reflect it about the x-axis again, and we're going to get 0.87, negative 0.87, 0.5. Okay? So, I think we filled in all of them now. Let's just check to make sure that our signs are correct. In this quadrant, we have negative x values and positive y values, so that's right. In this quadrant, we have both positive x values and positive y values. In this quadrant, we have negative x values and negative y values. And in this quadrant, we have positive x values and negative y values. Okay. Let's move on to the next one. Here what we're going to do, first of all, we're going to identify that there's 4 triangles drawn here. Each one of these triangles happens to have a 30-degree angle or 60-degree angle at the origin. And if this angle is 60, that means this angle is 30. If this angle is 30, that means this angle is 60. And of course, this angle is 90. So all these triangles are 30-degree, 60-degree, and 90-degree triangles. Then it says to use sine, cosine, on your calculator and find the length of each leg of the 4 triangles shown to 3 decimal places. Okay, so let's start with this one here. So we have a 30, 60, 90 triangle. Let's ignore the 60. All we need is a 30. So we have a 30-degree right triangle, and we know that the hypotenuse is 1. So I'm going to try to find out the opposite side. So I'm going to say, oh, the sine of 30 degrees is equal to the opposite over the hypotenuse. Let me make this bigger, make it easier to write. Okay, sine of 30 degrees is equal to the opposite over the hypotenuse. The hypotenuse, of course, is 1. The opposite, we don't know what it is yet. Let's call it x. So the sine of 30 degrees, if we look at the calculator, turns out to be, oops, make sure we put mode degrees. Sine 30 degrees is 0.5. 0.5 equals x. Oh, so our opposite side turns out to be 0.5 in length. Okay? What about the adjacent side? The adjacent side we find with cosine of 30 degrees. So we have the adjacent side, let's call it x again, divided by the hypotenuse, which is 1. What is the cosine of 30 degrees? Cosine 30. So cosine of 30 is 0.866. Hey, we were pretty close last time. We said 0.87. It's actually 0.866. Okay? So now we know that the adjacent is 0.866, the opposite is 0.5, and now we can write that on all of our triangles. This is the short side is 0.5, the short leg is 0.5, the longer leg is 0.866, and that's true for all of our 30, 60, 90 triangles. Okay? All right. And then what we do is we're going to fill in all of these coordinates here using three decimal places. This one's going to be negative 0.5 and 0.866. This one here is going to be negative 0.866, 0.5. This one here is going to be negative 0.866, negative 0.5. This one here is negative 0.5, negative 0.866. And here it would be 0.5. Oh, I'm sorry, negative 0.5. No, I'm sorry, positive 0.5, negative 0.866. And finally, 0.866, negative 0.5. Okay, so we finished with that page. Now we're going to go to the last page. What the last page is asking us to do is to find a few rotations, okay? And I'm just going to pick out a few random ones to do. And then just so that you can get the idea of how to do these, all right? So I chose these, all right? And the first thing I'm going to do is do the examples, but after that, you know how to do them. So rotate 3 o'clock by plus 30 degrees. And remember that a positive angle is counterclockwise, or in this direction, okay? So I'm going to rotate the 3-hour mark by positive 30 degrees. The 3-hour mark is here. If I rotate it positive 30 degrees, it would go to here. That would be the 2-hour mark. So then I write the 2-hour mark is where it ends up. If I rotate the 12-hour mark by positive 60 degrees, 12-hour mark by positive 60 degrees, that would be in this direction. 60 degrees would be 2 of these. I would end up at 10 o'clock. What if I rotate the 5 o'clock mark, the 5-hour mark, by negative 150 degrees? Now, negative 150 degrees would be the clockwise direction. So I'm going to take the 5-hour mark, I'm going to rotate it clockwise, negative 150 degrees. So that would be 30, 60, 90, 120, negative 150. So I would be at the 10 o'clock mark. I'm going to rotate the 9 o'clock mark by positive 60 degrees. So 9 o'clock mark by positive 60 degrees. 60 degrees would be 30 degrees, 60 degrees. I would be here at the 7 o'clock mark. Okay. Now I'm going to do these with coordinates. So I'm going to rotate the point 0.866, comma 0.5 by positive 30 degrees. So 0.866 times, or 0.5 is this coordinate here. And I'm going to rotate it, this point, by positive 30 degrees. So that would put me here at the 1 hour mark, which the coordinates for the 1 hour mark are 0.5, 0.866. Okay? Alright, now let's take the negative 0.5, 0.866 coordinate, which is here, and we're going to rotate that by negative 120 degrees. So negative 120 degrees would be clockwise. Negative 120 would be 30, 60, 90, negative 120, so it would be at the 3 hour mark, or 1, 0. Okay. What about rotating the 0.5, negative 0.866 coordinate? So 0.5, negative 0.866, that would be the 5 o'clock mark. And I'm going to rotate it by negative 150 degrees, so that would be clockwise 30, 60, 90, 120, 150, right? Clockwise 150, so I'd be at the 10 hour mark, which is negative 0.866, 0.5. Negative 0.866, 0.5. Okay. Last of all, I'm going to take the coordinates 0.866, negative 0.5, 0.866, negative 0.5, that's this one here, it's the 4 hour mark, and I'm going to rotate it negative 180 degrees. Negative 180 degrees would be put it completely on the opposite side of the circle. And you notice that if I would rotate it by negative 180 degrees or positive 180 degrees, I'd still end up at the exact same place, which is the 10 hour mark. So that's equal to the coordinates negative 0.866, 0.5. Okay, so I just wanted to show you a few examples so that you can make sure that you were doing it right, and that's it. Thank you.